G'day. There are times when I do bits and pieces and the subject really isn't all that exciting and so I'm not thinking of doing a whole video on it, but there are little bits and pieces in there that are a bit interesting. And so today's video is a collection of tips and observations and bits and pieces about a whole range of stuff that I've done. Some are TAD projects, some are things I've made for other people that I think might be worthwhile for people to have a look at. So please enjoy. This thing here on the end of the Allen key is referred to as a dog point set screw. I'll just move that around and see if you can get... So basically you've got a grub screw, a set screw there, with a plain shaft there. Now you can actually buy these things. Here in Australia, difficult. So I've actually made my own here, and I thought I'd show you the little jig that I made to do that, because it's rather simple, but you know, it gives you all sorts of opportunities, not only to do this, but if you wanted to set screw with a brass point or something, or a brass insert or something like that, you could use the same thing to do that. What you use these things for is if you've got something like this, where you only want to limit your rotation, you can have that so it sticks into the slot, and then basically it acts as a stop. So you know that there is a use for these things. Similarly, if you had a shaft, for example, with a groove all the way around, if you didn't want that shaft floating back and forwards, you could put something like that in there and stop it. So handy thing to have. The tool I have is just this. It's a piece of rod. It's drilled out to the bit over the major diameter of the grub screw, which in this case is M5, and then that's threaded, and it's probably about 10 to 12 millimeters worth of thread. And what I did was I put that grub screw in the end there with the amount sticking out that I wanted the tip, and then I put another grub screw behind it to lock it in place, and that enabled me to do that. There are things called lantern chucks, which are used for shortening bolts, but they all seem to, the ones I've seen anyway, all seem to require a head on the bolt. The thing I'm making up here is what's known as a shoulder bolt, and they are typically a shoulder, as the name suggests, with a threaded portion on the end, so you can see a little better. This is a commercial version. So there's a shoulder. And these are typically ground. This is an alloy steel when these things are made commercially, or usually. There's a thread on the end with some relief in there so that you can screw right up to that shoulder. There's also a little bit of relief here because that being ground, you need something to come up to. Typically the fastening mesh is a hex and the head is round. I've got this all prepped ready for milling. I'm going to make that into a hex top, and then I'm going to come in and put on the chamfer. Now, you've probably seen nuts like this before and never remarked on them, but if you look carefully you can see that there's a 30-degree chamfer, or 60-degree depending on how you want it, which means that contact surface is round, and the reason for that is so that doesn't chew up the thing you're screwing onto. And you can actually see that in hex head bolts as well. Some of them you'll notice have got a round part under there, which means they can be screwed right up to the surface and not have the corners of the hex chew things up. This is another application of fasteners or threaded connections, which is a little bit out of the ordinary. This is actually part of an arm for a walker, part of my volunteer work, but one of the things that I was asked to do was, could I make it so that a bar here could be detachable? So what I've got is actually a 1-inch NF thread there, UNF, and a corresponding nut. Now that was a little bit interesting to make because of the thread going up there, but I've done that before in threading videos. The important thing is I can have this thing sitting here. There's a little dowel pin on the shaft here, and there's a corresponding keyway there, and that was similar to the way I made up the stub shaft. There's a stub shaft video for putting in sort of a blind keyway or pseudo blind keyway. It's actually a through keyway which I've then welded a piece on, but that will go in there, so that now won't rotate, and then I can just use the nut to tighten that up so that now stays firm. So in plumbing terms, this is a barrel union, but that's just for joining two pipes together. So if you need to do this sort of thing, you want an inline type connection, this is another way of achieving that. This is an M6 screw, bolt, button head cap screw, and I'm going to put a 2mm hole in there so I can put a little bit of nylon. Now I think I've shown this to you before, but this is the bolt equivalent of a nylock nut, and you have to tune the length of nylon, and I'm going to just use some whippersnipper cord carefully, but what it means is I can put this into a nutset and this isn't going to sort of work its way out, or at least not work its way out as easily. That's the finished result with a piece of nylon whippersnipper, line trimmer, whatever you want to call it, strimmer cord in there. If you wanted to, you could put a dot of super glue in there just to retain it, but it seems to be pretty good. There's a little bit of hit and miss there. I've got this one, it's probably just a smidge short, but you know, that's one of those things you're going to have to try and see. To cut it, I put a bit of tape on it and then used a sharp knife to slice a piece off. I didn't want to run the risk of this thing flying all over the place, so that gives you something to hang on to. This is my tube bending rig. I can't recall whether I've shown this before, but a couple of things I thought I'd mention as we're doing a few tips and things. Firstly, the diameter of that roller should be around about 4 times at least the diameter of the tube. This one is pretty marginal. It was built for something else and for a purpose, but if you get less than that, you're going to run the risk of crushing the tube, and I'll show you that in a minute. I grasp the tube in here. Ideally, when you're bending tube, you want a little bit of slip, but you know, I can't get that, so instead I clamp it and live with the results. However, if you're ever in a situation where you've got a steel-on-steel contact which isn't clamping enough, put a bit of paper in there. The coefficient of friction between steel and paper is greater than the coefficient of friction between steel and steel. And we used to use this in the white goods business for putting things onto, well, bolting steel to steel. We put a paper shim in there, and that would increase the friction. So that's a handy thing to remember, is if you're trying to clamp some steel up and it's not quite working for bending or whatever, then you know, a bit of paper might help. This is the result that I've got out of my first bend. As you can see, it's marginal. I've got some flattening on the back. I've also got a little bit of buckling on the inside. I can probably fix that just by putting a brace across there. That won't weaken that too much. As it is, I think it's going to be strong enough for what I want to do. But that's sort of the failure indicator. Bit of buckling, flattening of the tube. You can fix that by packing the inside of the tube with sand. You just have to be careful what sand. I used some paving sand once and it had some binders in it, and so by the time I tried to get it out, the binders had sort of really bonded to each other. I'd applied a bit of heat, and so I had all sorts of strife getting that out. So if you use sand, make sure you use just plain sand. This is a clamp block that I've been asked to make up. There's a diameter 32 tube that goes through there, and this just clamps on either side, and then there'll be a spigot welded on the other side there. Nothing terribly special about it, but I just thought I'd show it to you because two things. One is I'm using my preferred method of boring a clamp block. I've got some 2mm aluminium in there, and that'll just space it out so that the bore has got room to clamp. The other thing is that this is based on a bit of recycled material. I had it sitting around the place. I thought that'll do. It had a hole round about the middle, so I thought, yeah, that's a good start. But I can't run a drill down there as I normally would, because the drill's just going to kick off. I want the hole centralised. So what I'm going to have to do is run a an end mill, a slot drill, straight down the middle of that to give myself a hole which I can then get the boring head into to make the hole. So the other alternative would be to make up a plug of some sort, put that in there, and then I could drill. But just as a tip for trying to bore a hole, should we say off centre where there's an interruption to it, that's the way you might attack that one. One of the problems with a block like this is made out of 2 bits of square material. So there's a lot of material there that's not required, but there is some that is required, like where the bolts are. So I've clamped this onto a bit of pipe, and now I'm coming in with my profiling tool, and I'm putting a radius in there, just trimming that back. I'm going to put something between here, and then I'm going to run along these, for want of a better term, ridges with a rounding cutter, just to take the sharp corners off. That should save me a bit of weight, but also make it look a little less lumpy and all that sort of thing. Then all I have to do is weld on a spigot on the other side there, and it's pretty much done. Right now I'm welding up the corners of some ashtrays. It's one of these projects I do for TAD, and the cigarette will sit in there. It's for someone who can't hold a cigarette. And I want those corners to be welded up so that the ash doesn't spill everywhere. So I've done the sheet metal work, that's all pretty straightforward. But here I'm welding up the corners. Now if I'm doing a box like that, I can put a bit of aluminium behind that, and that serves 2 purposes. I can use that to hold the corner, and in the case of something like some stainless steel, it means on the inside of the weld I don't get, well, I call it bloom, I don't know what other people call it, but basically if you look at that weld there, that's just a weld on one side of some sheet, but on the other side I didn't exclude the oxygen, and so I've got this black horrible stuff. And that's actually not too bad. Some of it can be really, really bad. Okay, so what using a block in here does is helps exclude the oxygen. Now, that's fine, but if you've got an angled thing like this, it's not a 90-degree corner. So I've made up some blocks like this. This one's actually 103 degrees. A friend of mine who's a mathematician says it should be 104, but I'm prepared to spot half a degree. But I can put that in there, and using an assortment of clamps, hold that in. It excludes the oxygen, allows me to shoot up the weld there, and everything's wonderful. I've got an outside and an inside corner, and that's so that I can put it on the back there and weld up on the inside if I wanted to. I can't in this particular case because I've got a safety edge on here, which is stopping me getting right in there, but that's the theory. So that's my tip for welding funny angles. Anyway, I hope this will all be of use to someone, and we'll see you for the next one.